Good afternoon, everybody. This is Mark Flamer, working remote out in California. So last year I did a presentation for Innovation Week, and I called it VectorSim. It was a PowerPoint presentation basically presenting an argument for including finite element analysis tools within Vectorworks. So we already have SIA, and we have complex, expensive analysis packages for doing structural analysis, fluids design, thermal analysis. But why wait until that far into a project? Why not provide the user with the tools up front? Why not give an architect these tools within Vectorworks so that he can, at the beginning stages of design, do this analysis when it's really easy to make changes? And I wanted to point out that our competitors have already started to include these features as well. So this was sort of my mission statement for my presentation last year. And so what I did this year is I went ahead and I decided to do some prototyping. So instead of going out and starting from scratch, there's lots and lots of open source libraries for simulation and finite elements. So what I did is I chose a pretty simpler library, one that I knew I could get going quickly. It's actually not one of the ones here shown on this list. And what I did is I spent a couple of days and I built a plugin object that leverages this. So I'll demonstrate that now. So before I get into the demo, I'll just give you a quickly show you just a little bit of the code that was involved. So what I did is I found this library, and I brought it into I built a plugin object, and imported the library in here, and with about, I don't know, only a couple hundred lines of code to first get the path. What this is I'm calling it a planar analysis model. So it takes a 2D object, a polygon or polyline, out of the path group of a path object, and then it meshes the boundary, and then it creates an interior mesh, and then it builds up a list of finite elements, boundary conditions, and then runs the analysis and produces some results. So not a lot of code. It did take took a little time to get everything kind of working together right. I think I spent a couple days altogether from beginning to end on it so far. And so this is what it looks like. So here in Vectorworks, I've got just a simple polyline in sort of a beam shape, and then I wrote a script that'll wrap this in that new planar analysis model. So we'll go ahead and run the script, and I will first talk about some of the options here. So I've got a mesh size setting. We've got some material properties, the modulus of elasticity, Poisson's ratio, material density, the thickness of the object, because remember, this is all 2D elements. It's a planar model. So the thickness is the thickness in and out of plane, so in and out of away from the screen. And then some different types of results to display, and then we can magnify the deformation so that it's more apparent. So we'll go ahead and take these defaults and see what happens. So that's not a very fine mesh. Let's go ahead and adjust that. We'll make that 20. There we go. So you can right away, it runs on a small model, it runs really fast. So this is the deformed shape of that beam. Now the only loads that we have to apply at this point it's just gravity. So gravity is in the negative y-axis, so pointing down here, obviously. Ideally, with a little more time, I would have added the ability to add different types of loads. We could do thermal loads, we could do forces, pressures, moments. So just gravity for now. So there's the beam under gravity, and then if we go to top view, we can see the stresses. So this is the stress. Red is more intense than blue. And working with Chris Gray, he implemented a method to color in a more smooth method, colored by vertices on the mesh. But I couldn't get it working with the amount of time I had. So it's there, and obviously there'd be many other ways to show quantities, stresses, and extract data out of this model. But the bottom line is that we've got this quick, simple way to perform analysis on real world materials right here in Vectorworks. So let's go back to top plan, and all right, so here's a poly. Let's go ahead and create a model out of it. I know it's going to need a much tighter mesh. We'll try 20 and make some adjustments. Okay. So there's sort of a little building structure, and you can see it is deflecting there. It did sag a little bit. Let's go ahead and look at the stress distribution. Obviously here at the hinge points we've got quite a bit of stress. Now let me jump into the path group. So if I double click, go into the path group. So the way I'm handling supports in this model is that any edge that the user has chosen to be invisible, any non-visible edge is considered fixed. So those are our boundary conditions. So if we go back to the simple beam example, I'll show you what that means again. So if we were to use the reshape tool and then make this edge visible and then leave, wow. So clearly a big difference there. There's our sagging cantilever. Okay, so not really complicated or really extravagant at this point, but what's exciting is that from this point on, there's so much. All the pieces are there. So I've got this solver. It's hooked up. From here on out, it's all about user interface and just basically exposing more of the tools to the user. And what's exciting is there's just so much available in Vectorworks. I mean, we've got everything here, so we're so far ahead of like creating a new analysis package from scratch. Anyway, so I hope it was interesting. I think that with a couple weeks of development, there could be a nice little product that could be shipped along with Vectorworks that might generate some interest. So, thank you.